dash mark. Okay, so you got that little mark right on top, and then you type in a number. So therefore, you had to press this symbol first thing, and then okay, for the 2, it'd be 0, 0, 1, 0. Okay, to represent a 3 would be 0, 0, 1, 1. Okay, so that would be BCD for 23 decimal notation. Okay, and the next one, same thing with this bottom one too. So start with this little symbol. So it's not usually you have double quote. They just do a single quote. So start with a single quote, and then we have then 7 would be 0, 1, 1, 1, and 9 would be 1, 0, 0, 1. Okay, so this is following exactly the sample teach you about BCD from the handout. Okay, and then once you type that in, make sure to press enter. Okay, so now next one, same thing. You start with this little mark, and 7, it'd be 0, 0. Oops, come back in here. 0, 1, 1, 1. That would represent 1 of 7, and then 0, 1 would be 0, 0, 0, 1, and 8 would be represent 1, 0, 0, 0. Press enter. Okay. Okay, so 9 the same way. So 9 is 1, 0, 0, 1. 1, 0, 0, 1, and then 1, 0, 0, 1. Okay, so that's a represent 999. So once you type that in, so that should be so once you type that in, you can also check it. So therefore, you come in here and just highlight this whole sheet and Control C on your keyboard, and then you go to the next sheet, and you can click here in the first cell, and just you click on with the second clipboard called values. Okay, click on that, and then it would tell you which one you have that is correct, which one is incorrect. Okay, so if I scroll down to the bottom, okay, so now you got 1 point, 1 point, 1 point, 1 point. That means all this is correct, and the one down here is all correct too. Okay, so if it's incorrect, go back and retry it. Okay, so this one up here, you can do it yourself, and that should be pretty easy. Just fill it from the sheet here. Okay, use this from decimal to binary, and from binary to decimal. Okay, or from binary to hexadecimal, hexadecimal back to binary. Okay, so the top part is easy. So the bottom part, just use the hand. Like I said, just use the handout to do this. Okay, so this is how to do encoding for BCD. Okay, so like I said, when you look at this one, BCD, and you put your cursor on it, and your hand what comes up is that to enter data in the file, you need to press the single quote key first before you type in the answer. So for example, in this one, you push that single quote, and then represent 2 would be 0, 0, 1, 0, and represent 3 would be 0, 0, 1, 1. Okay, that would be 23. Okay, so that is okay, so that was one of the question that was that they need help with. Okay, so the next thing later on, so that is the things. And also like Mr. Pham said, we're gonna be if you guys planning to build a circuit board, we're gonna need to we need to start collecting names of students who want to purchase the breadboard, so you can be able to do your lab for D-Lab for your first D-Lab 1, which is let me see. So D-Lab 1 would be so first D-Lab 1 would be this right here. Okay, so so if you can type in the chat if you want a board, so that way you can let me know, and you can send me a private chat that you want to get a board, and pretty much the board, it would be $27. How do we come up with that solution? Well, if I can go, this is what you see in so if I go to Amazon, so Amazon, So Amazon right now, you got they only have one board available, this one right here. The rest would be on back order until the 18th of March. Okay, so this is the only one that's available, and it's running about $27 a piece. So that's what we're going to be selling to you guys when we order. So this one, like I said, this is the price per board. This one without the taxes and shipping or anything like that. So we're offering it all to the student for $27 per board. Okay. So it'll look like David want to get one. Okay. So David, okay. Okay, like I said, the pricing would be in the same, matching whatever it is that is being offered. You know, I can't find anything else that is cheaper than this. So this is the most affordable one that I can find. The breadboard is right here. The dimension is 7.5 inch wide by 7.25 inch length. So it should be some. Let me see. Stop there. Stop sharing. Okay, so we're gonna be stop sharing. So it would be a breadboard. It's similar to this one right here. Okay, it's about this dimension. Like I said, it was about 7.5 width by 7.25 inch length. Okay, so similar to this board right here. So that's what you're going to, so that is the requirement for you, but all the other tools, we have them available. Now, if you want to make some purchase on yourself, like I said, and if you want to make any purchase yourself, you can go to like I said, go to Amazon. Like I said, this board is only one available right now because I did check. And they said the rest would be on back order, and then it is from Jameco company. So and that is for $27. Now the other tools that you potentially if you can afford to purchase them, it's one of them is called a flat nose pliers, and you want it to have a smooth jaw. Okay, so you don't need to buy that. We have it available in class that we can lend out to you to use. But if you want to make a purchase yourself, if you can afford it, go ahead and do that, because you will be potentially need it in your career if you want to pursue the electronics really well. So like something like this is really good. Okay, so it has a spring in between here, so it would able to open up automatically for you when you do it. So less time that you had spent opening up and closing it. So you can do a lot of research on Google's, and you could be able to find most of these information. But like I said, most of the things I found was so these are the things that that if you want to get it. So the other thing is mainly we're going to be using a 22 gauge wire. So 22 gauge, you don't want to get stranded. You want to get a solid. Okay, so solid wire. Oops. So let me see. So you want to do is don't get the one that says stranded. You want to look at the one with the solid wire. Solid wire would be something similar to this one here. So if you look at the core inside, you have a single strand. You got a solid wire. So that way, when you put into your connection onto your board, it will go into that connection point easily. As you can see, once you strip out the insulator, and then you can stick it into the hole, into the connection on your breadboard. So that's will make it very, very easy. Okay. So like I said, that's the thing that if you want to purchase them for yourself, that'd be great. So the other one but these are not, like I said, the only essential is that you need to get the breadboard. Okay. So breadboard, I will be ordering them. So you're going to get the price at around at $27 a piece. Okay, that's the best deal that we can offer you. This one is not, this is price here is without taxes, without shipping and all that. So therefore, we're offering you at the same price as Amazon, which is at $27. Okay. So the other one, the other tools that you probably need, probably a wire cutter. You want to get a small one that mainly we're going to be cutting is mainly probably a 22 gauge wire. So like I said, we're going to be mainly working with 22 gauge wires, solid strand, okay, solid core wire. Okay, and the other one, the other wire stripper is this one right here. So you can get a wire stripper. It's very, very good. So we have these, so most of these, okay, let me go ahead and stop sharing. Now, these tools are available. Now we do have these available in the classroom that we can lend out to students to use through the semester. Okay, so this is good because it has an automatic adjuster here for setting up the gauge of the wire. So you got a 24 gauge, 22 gauge, 20 gauge, 18 gauge, 16 gauge. So you have this gauge that you can set up. So you can set it up exactly to match up the wires that you're going to be stripping, and you're going to be pretty much set up wherever you need it. So this is represented 22. So 20 would be here. And then now this one has a locking mechanism here. So this one has a locking mechanism. It has a slider here. So you could pull that up. Now that one's locked in place. So unlock it, just push this one up and it release and open. Okay. So you can get something like wire stripper like this, or you can get a wire stripper like this. Now this one has it has from a 20 gauge all the way up to 30 gauge. So we're going to work with a very, very small wire at 30 gauge. Okay. So this one is also good. You got a locking mechanism here. But like I said, these are not, you don't need to purchase them. We're able to lend you these from the classroom. But the only one that you need to make a purchase on is the breadboard. Now we will order it and then you can buy it from us when it get delivered to the classroom. Already placed the order. It should be coming in within this week because it's coming directly from San Francisco area. That's their headquarters. Okay, so it should get here within, it should be getting here pretty fast. Okay, so and then when you when you get to the classroom, just bring your money. Like I said, it's $27 to cover the cost of the breadboard, and then so we can be so then we can teach you how to use the breadboard to do your lab. Okay, so anybody have any question?
And you know that the really cheaper one.
Yes, that is the most.
For the breadboard. Yeah, I go to the circuit cost $35.
Yes, so yeah, those are pretty expensive. So you can see. So if I look at this breadboard here, you know, this is from Circuit Specialist, and they're the oops. Yeah, this one is we usually get this breadboard from Circuit Specialist, and they're running about $35 per each one. That is not including shipping, and that's not including tax. So, and then if we order in bulk, it's going to be cost us at least $32 each board. Okay, same thing if you look at Jameco. Okay, so Jameco, you have this one here. So Jameco, you have this one right here. So you have this one is at $37 or $38 a piece. So 35. And then this one is all in back order. They're not going to get it ordered until they sell ordering. So I don't know when they're going to get it, but they said they're going to get it in by March 18th. And right now we have so much problem with supply chain. I don't know if they will get it by 18th. And so everything else is on back order. Okay. So like I said, I already pre-ordered some of the board, and so by the time we should get it by within this week, or the latest it would be by next week, and then we can be able to. And then you have to do just make a purchase. And like I said, we're going to offer you at the same price as what you see here on Amazon. You can buy it yourself at Amazon, or you can wait for it, and then you can purchase from us. Okay. All right, so that's pretty much it. And so if anybody have any other question, please let me know, and we'll definitely be able to share more. Okay, thank you.
Okay, thank you, Sam.
You're welcome, Mr. Pham.
So let me change to my iPad. Okay, so hello everyone. Okay, you can get that you done faster than on the tech one. The thing is on tech one, you depending on the level. You don't have a level at home, so you must have to get into the class. However, on tech two, you can build the circuitry at home. Okay, and only thing you need to buy is the breadboard, and the rest we try to let you borrow it until you complete it. Okay, like the wiring or whatever needed for you guys to build the lab. So whoever done on the lab phone and also will be done on the lab, the labs will be get certificate in this semester, no problem. Okay, so now today we will be trying to get a little more thing, okay, to be done. Before we go to the logic yet, that is not hard to do, okay? However, let's see. I want to make sure you understand few things. Last time we're talking about Boolean algebra. Only thing I want you to memorize the Morgan law. That will be converting. Okay, product to sum. Converting sum to product. Now, if you get not A and B, that are not, you want to break the bar over A and B. A and B, that means the product. So if you want to break it, that bar, A will be not A. B will be not B. However, this is the A and B. They come out to be not A or not B. That will be the sum. Okay? And if you get not A or B, so A will be not A. B will be not B. All now will be turn out to be N. So that means you get a sum you converting into the product. That's the only thing I need, okay, for you. The second thing, they say implement. Same thing like they want you to draw the circuit. for the expression. Okay, you get a y equal a and b, or not a, b, or a, b, c. You know, this is the expression. If you're looking into that expression here, can you tell me how many inputs?
3.
3 input.
3. Exactly. 3 inputs. That will be A, B, and C. How many output?
1.
1. Correct. Now, you understand me when we design the circuitry in a digital, then they have to telling you how many input they wanted and what the output supposed to be. Okay? And after that, you have to get the truth table in order to collect the data for the output. Okay? And now I'm talking about they want to build. How can we draw this circuitry? Who know how the way or the rules, how to draw the circuit? First thing, what you have to draw? What they telling you? Draw and first. Second, draw inverter. Number 3, draw OR. Okay, that you have to follow that procedure in order to draw that circuit for the y equal A and B, or not A and B. So the first thing you draw AND gate first. And the input will be A, B. And the output will be A and B. Okay, so make sure if you not follow it, okay, let me know. That means you already draw for that AND term, that one. And you go to the another AND, not A and B. So now you get another AND. And you get A right here. You want not A. That inverter. Not A. And B. You can connect that, go to B. So that one will be not A and B. Okay. Let's see, we try to make this longer. Now, the last one, you done on that. Last one will be A and B and C. Okay, now you get an A and B right here. Okay, and you only need will be C. So you get the gate. Okay, draw that one here. That will be A and B. And now you're adding C. So this output will be A and B and C. So that on off the AND gate we already done, or inverter. And now we have to draw for the OR. This is the first OR here. A and B, OR with not AB. A and B here, not AB here. So you get an OR gate.
Mr. Pham, could you repeat that? Because you weren't using your cursor and we didn't see what happened.
Okay. Yeah, I can tell you. Okay. You get the A and B right here. A and B. OR. Now I draw for OR. OR not A and B. So this is the OR gate. Okay. And then you can connect this one here. Go to the OR gate. Okay. And this one will be not A or B, not A and B. So at this one, you get A and B, or not A, B. Okay, that means you're done for this guy. And now we go to doing that one. That means you want A or not A, B, or with A, B, C. This A, B, C, and this is the one. A, B, not A or B. So you get another one, or get. And that will be Y. That's how we implement the circuitry. I just try to let you know how to do it, but you don't have to do it. The thing is you get a simulation. Okay, that's easy for you. So any question on this thing?
Yes, Mr. Pham. My question is, you said on the procedure, what I'm trying to find out, is there like a B, C, D, E, F, G way of doing it? So when you very first started, you said you have to do the, I believe, where you got Y equal AB plus A not B and then ABC. Is that for this circuit only, or does it change if you have a different circuit?
Right, that's for this circuit.
Only.
Right. Cannot
So-
apply in general.
It does not apply in general?
Right. That means that depending on what they given you the expression.
So
And
there
you
is
draw-
no, so there is no set, there really is no set procedure except for individual circuits.
Exactly. But you have to follow the rules.
Okay, all right.
You draw the end first. Next will be must be inverter. And the OR gate will be the last one.
And that's for any circuit that you would get. You
If
draw
you
the,
want to implement.
okay, so you draw the AND gate first, the
Right.
NOT gate second, the OR gate third, and then it's all subject to the individual circuit because it's different circuits.
For any circuitry.
Okay, okay.
Okay, now, if you're looking on this circuitry, how many gates do we get?
You have 6 gates.
Come on. You can count
You got
Five.
one,
You have
two,
five.
three.
5 gates.
5 gates.
The knot doesn't count as a
One.
gate?
Oh, 1, 2, here. 1, 2, 3, 4, 5, 6 gates.
That's what I said, 6 gates.
You're right. I didn't recognize inverter.
Yeah, right. It's 6 gates.
Okay? Now, normally when you draw that 6 gate, basically they not built. Okay? They have to using a Boolean algebra to make simplify the circuitry in order to get the minimum number of gates. Then they can build. Okay? However, Boolean algebra that's a long time ago. They're not using anymore. Very hard to do. So later on, they're coming up with the Kano map, K map. That's what I will be teach you. Okay? How to do it. K map will be more easier. In order to simplify the circuitry, they want the same output, but they want to get a minimum number of gates. After the simplify, maybe you get only 3 gates instead 6, and they do the same thing. That means output will be come out with the same thing. That's the reason why they're using Kano map, okay? And that's what we want to go through with you today. So that will be let you know. If you get an expression you want to implement, you can draw the circuitry. And you have to follow the rules. Draw N first, inverter, and finally will be all good. Okay? If you get any question or confusion, just bring it up to me.
Yeah, Mr. Pham, what the plus sign again? What was that defined as being when you have the plus?
This plus sign right here,
Yeah, you drew the like the N above the plus. Yeah, what's the plus? That what is that definition? Or gate. And then when you apply the C is technically not or gate. What if C is
here,
yeah.
nothing to do with that. See, it's just a variable.
Right, C is variable, you're right. That's why I just wanted to clarify, because A technically would be AND gate or and then 2 draw inverter. That's obvious. That's draw the inverter. So B technically is just a pin, and C is a pin or an input. So or is the OR gate plus and the plus, or just the OR gate itself? So you have the plus, that's OR, but then you have the OR gate.
You're
So-
talking about that one.
Right.
Okay, now, if you're looking at up into the equation here, this is the R right here. Right?
All right. So I understand.
A and B.
Right.
All with not A and B. Not A and B. Okay?
It can't be a negative, right? So,
What do you mean negative?
well, I'm just saying A plus negative, you're A, B, negative, A not B, negative, A, B, C. So if you replace the positive with a negative, then what would the schematic look like if it was a negative instead of a positive? What would the symbology mean?
I don't understand what you mean about negative. We don't
Well,
have any negative.
no, that's what I'm saying. It looks like AB plus AB plus. So if I say AB negative, what would a negative mean? It doesn't mean opposite of or. Is negative a symbol reference? You
No.
can't.
You
can't.
understand in that one, in the digital binary system, you don't have a negative. You
Right.
understand A and B.
Right. No, I understand.
Now, what you mean for a negative A and B?
Well, that's what I'm in the interpretation of math. That's what I'm interpreting. So plus I'm interpreting as an addition. And then if it was a negative, it would be a subtraction. So I'm looking at this.
No, we don't have that.
Right. All right. Thank you.
Okay, now we already get to and get here. Okay, only thing I want to make sure the part for this IC 7408. Okay, if you're looking on this IC, they get a 14 pins. 1, 2, 3, 4, 7, 8, 9, 14. Normally, IC for 14 pieces. Then normally, pin 7 will be connected to the round. Pin 14 will be connected to 5 volt. Okay? Without that connection, the IC not working. So that's why when you build a circuitry, the first thing you have to connect the power first. Then you connect the round. Okay? And if you're looking inside HIC 7408, they get 1, 2, 3, 4 gates. And they can telling you pin 1, pin 2 input of the first gate, pin 3 is the output, and so on. Okay? So what they said, output of the AND gate is 1 if on input are 1. That means the AND gate get a 1 input 0. Output will be 0. Now, you can see I can draw AND gate here. A, B, the output will be A and B. So if I say A equals 0, what output?
0.
0. The reason is A0 and B, anything and 0, same thing like anything time 0, they have to be 0. So B, you don't care. Later on, you can see they're talking about I. That means don't care. Okay, anyone understand what that means for don't care?
You can put whatever you want, a 1 or a 0.
Don't care means I can be 0 or I can be 1, doesn't matter. That means don't care.
But for AND gate, the only time you can get a 1 is when both inputs are 1. Otherwise, the output is always going to be 0.
Okay, if any one of the input of the AND gate equals 0, output must be 0, no matter what. Okay, so now I get talking about you get an interview with me. I given you that AND gate. I say A equals 0. Can you tell me what the output? If you say you need to know B, then I say thank you, thank you. The thing is, you not understand. A0, no matter what output, must be 0, and B, we don't care. That means doesn't matter B equals 0 or B equal to 1. So now, if the output here 0 but not 0, that means something wrong. Okay? Something must be wrong. Not 0 mean maybe they get 1 volt. Maybe they get 3 volt in logic 1. 1 volt at least, that means not allowed. What can you do? Okay, now you said you check that input at A to see what logic. Check here. You take a meter. Measure at A. You want it 0. So you say, okay, that's what I want. And what else? What you want to do? What I said is, the output telling you something wrong. You want 0, but it's not 0. And now you go into the input to measure at the pin A. You want 0. And now you get a 0. Next step, what you want to do?
Change the IC.
Exactly. You change that gate or change that IC.
Because you've confirmed that you got a 0 at point A. So you know what's going in is okay, but what's coming out is wrong. In other words, you have the right input, but the wrong output.
Exactly. That is troubleshooting. Okay? That means when you measure the output, you get something wrong. And you have to check the input. If you get the right input, that means that part is not working. Okay? Now, after you check A equals 0, you get 0. If you go to a check at the B, then sooner or later you get layoff. The thing is, we say we don't care. Don't care, that means either 0 or 1, that be fine. How can we have to measure? So now I hope you understand what that means for don't care.
Mr. Pham, just one quick question.
Yeah.
When you determine, like say on this particular thing we're working on, this particular gate doesn't work, but we have within that chip, we have 4 other gates, and say if we were only out of that chip, we was only using that one gate. We couldn't use another gate within the same chip as opposed to get a new IC.
No way. No way.
The company don't allow that?
Not allowed. The thing is, the board on the company, they already lay out the wiring in the middle. Okay? So you cannot change any wire.
Okay.
Only way you can take that IC out, put a new one.
Okay.
Okay?
Okay, I get you.
But don't say, I using that pin 1, 2, 3, this wrong, now I can do that one. Now you can do at home. But in the company, cannot.
Oh, I see what you're saying. It'll work if I do it because we using breadboards and simulators.
Right. You're using a red board.
But at the
Exactly.
company, they don't want you to change the wiring pattern.
Cannot change it.
What if you have to wait 5 months for a new IC? Can you use jumper wire? Trick question, Mr. Van.
No. You understand it normally, you're working in the company circuitry, okay?
Mm-hmm.
And basically you cannot touch the wire. The wire will be run in the middle of the layer, okay? So you cannot see the wire. It's not like a left phone. That a left phone just built normally simple.
Do they consider that like modifying what the engineer did? Is that correct?
But you cannot connect the wire from one pin to the other. Can we damage the circuit board and you get a
Okay.
problem.
Okay, thank you, thank you.
Yeah, your job will be, you say, okay, this IC not working. Give them to assembler. They can it and they give back to you. That's it. That's it. That's the end gate. The next gate will be all gate. Okay, the part number 7432. Okay, and also you can see, okay, did they all get A or B? You see that? We get equation right here. Y equal A or B. If you want to know the output, looking at the truth table here, okay? 0, 0, you get 0, 0, 1, you get 1, 1, 0, you get 1, 1, 1, okay? But up to understand, you never have to see that one, okay? And what they say here, output of the OR gate is 0 if all the input are 0, okay? That means you get a 0 A, 0 B, then you get 0 out. However, if you get a 1 here, okay, then output must be 1. Why? The thing is, did whatever, I don't care. So you can say 1 or with don't care. They can be 0, they can be 1. Okay? So that means 1 or 1. 1, not 2, okay? 1 or 0. 1. That means anything or with 1 must be 1. That only telling you for the OR gate, 1 input equal to 1. Output have to be equal to 1. However, if you want it to be 0, then this have to be 0. This have to be 0. Then you get a 0. Okay? And the OR gate 7432. And the same thing. Inside the gate for gate and power and ground. Same thing. 14 and 7. Now, inverter, 7404. Inside it, I see you get a 6 gate. Okay, you can see 1, 2, 3, 4, 5, 6. Okay, and also round will be 7. 14 will be power. Inverter. Only thing is, you can see inverter here. 1, then you get 0. And with 0, you get 1. Just inverted. And now you can see you get 1 here, 1 here, 1 here, 1 here. So if you get a 1 here, what you get output here?
Could you
What
repeat,
output here
Mr.
equal?
Pham?
1, 0.
You get for inverter. If you get an input at logic on 1, what the output you get?
1,
0.
1, 1.
You can do.
You have
One.
one, you have one, then
Then
you have
zero.
zero, then you have one. then you
Zero
have
Oh,
and-
zero, then
okay,
you have
okay,
one.
okay, got it, got it.
Okay. Now, how come? Sometimes you can see this kind of circuitry. Okay, input and output, basically the same thing. They don't need the inverter. However, they need it. I'm telling you how come. When you get a 1 here, be for output to be a 0. Take that about 10 nanosecond. Okay, they call it propagation. That means the time. Okay, for 1 in here to be 0 at the output. So the total here, you can get 40 nanosecond. Correct? H1 you get 10. Converting from input logic to the output logic. And sometimes you don't understand in digital they deal with the timing. That means at a certain point, signal coming in have to be what they wanted. However, sometimes the signal coming is earlier than they expect. That's why they're using inverter to slow it down.
Well, it's technically a clock, isn't it, Mr. Fran?
No, it's not clock. That's the signal. But that try to delay signal for, in this example, 40 nanosecond before they come to the 1.
Mr. Pham,
Yeah,
the 10 nanoseconds that take the process, it is only for gates, or it is only an example that you're giving, or that is the technical number associated to the delay?
now that you want it, you can look into the data sheet.
Okay, okay, got it, got it.
Yeah.
I understand your point. Thank you.
That is a propagation time.
And it's not to be interpreted.
it.
It's not to be interpreted as a capacitor.
No, nothing to do with that. Okay, and now here, NAND. So basically you can see, IC will be the same thing for NOR, NOR, whatever here, okay? You see the NOT here, that pin 1. 1, 2, 3, 7, up 14, okay? And this is the NAND. NAND means not AND. So the symbol they're using, this is normally A and B, okay? And not in here means inverter, okay? So basically, before the NOT, you get A and B, okay? After the NOT, you get the bar over means the NOT, not A and B. However, I don't want this one converting to the sum. What y equal? I don't want product, I want sum. That's the Morgan law. Tell me what you get. We just did it. A will be not A. B will be
Not B.
not B. And now will be R.
Or,
Okay, I need that. The thing is that will be easy for you to know what output if you get an input. For example, if A equals 0, what output?
the not A output would be 1.
Okay, so you can say y equal not A That means not 0
Yeah,
There
that
will
would
be
be
a
a
one.
one,
or not be, right?
right,
1 or anything will be
one.
1. That's only telling you one thing. For the NAND gate, 1 input equals 0. Output must be 1. The other one you will be don't care. That's the key point. I already memorized this one. Okay. So if you want to learn by truth table, that's okay. You look into the truth table here. They given you input and they given you the output. Okay. However, now I given you the example. 1, 2, 3. So you get this 0. What output? For that,
One,
get
one,
the output I said must be 1.
one.
Okay. You get 1 input, 0 output must be 1. The other input we don't care. However, in order for the output to be a 0, okay, that will be asking for 0 and 0. Then the output 0. That means all of the input must be 0 in order to tell it output to be a 0.
Hey, Mr. Pham,
Yes, sir.
according to your data sheet there, to get an output of 0, your inputs, all of those, and that's the NAND gate, all your inputs need to be 1.
Oh, sorry, sir. Yeah, you're right.
All the inputs need to be 1 for that to be a
Right,
0.
exactly. That means that have to be 1,
1, 1, 1.
1, and 1. Then output to be 0. Okay?
That's one thing about looking at the truth table. You can see it right away.
Right, but the thing is that's what you have to memorize.
Yeah,
For the NAND gate, 1 input equal 0. Output must be 1. However, so for the output to be a 0, on input must be 1.
right.
Okay? Now, they given you another one simple right here. They put a inverter in the back here, but they working like a NAND. Otherwise, you going to work in the company, you see that I see this gate and you don't know what gate. They just a NAND gate. Okay?
The symbol looked like an OR.
Look like the OR, but it's not. That
Mhm.
will be the NAND. Okay? Now the NOR. Same thing. Okay? For the NOR gate, I prefer this equation. Y equal not A and not B. Let's see. A0, B0. Output is 1.
1.
Okay? Now, that's just telling you one thing. For the NOR gate, one input equal to 1, output must be 0. You can recognize that. A equal 1, not A equal 0. 0 and with anything will be 0. So for this gate, in order for the output to be 1, then all the input must be 0. Okay, you can
Mr.
see,
Pham, did you say this, this is the same thing as saying not or?
not or.
Or.
That's inverting of or.
Okay, yeah, okay, yeah, got it.
Okay, and the IC will be the same thing. Forget. Now, next one, exclusive or and an exclusive nor. So when you see this symbol, okay, then you know the name, exclusive or. And you see the same thing, they get inverted here, exclusive nor. And this is the truth table telling you what the output, okay? They're just telling you, if you get the same input, output 0. What that mean? If you get a 0 here, 0 here, output 0. If you get a 1 here, 1 here, output 0. The same logical input, output 0. However, if you get a different logic input, then output equal to 1. That means you can say you get 1 here, 0 here, so you get a 1. Different logic. Or you get a 1 here, 0 here, you get a 1. Okay? And then exclusive nor just inverted of the exclusive or. If you want to know output, you can look into the truth table. Okay? However, try understand. So you later on you don't need the truth table. Exclusive or you get a logic 1 output if the input at a different logic. If they same logic, output will be 0. Okay, that's it for logic gate. And now we can go into another handout. That for Boolean. No, K-map. Let's see, take you number logic from here. Let's see, I make sure the Morgan law. No, that's not the one we wanted. Okay, I did it to K map here. Okay, that for Kano map. This is a Boolean. We already given to you. Okay, and next one. You see that? They say simplify expression y equal a or ab. Okay, so basically they're using a Boolean. Okay, to simplify, finally you get y equal a only. That means you connect directly to a, you don't need any gate. So on this one, easy, so I can do for you. They equal a or ab. So you say A, take A, you get 1, and you get B. Correct? That is using the Boolean. You can see right here. A or AB equal A. So 1 or B, 1. 1 times A, and A will be A. So basically, on this equation, you just connect Y to A. You don't have to build with the two gate. That I just bring it up to you. For the circuitry, they need to minimum the number of gates. Okay, using the Boolean. And this is just an example that you can read it, the thing that will not apply. Okay, and this is the Morgan law, we already done. Okay, we don't care that. Okay, so this example, okay, you want it, you can do it. Now, I'm talking about that one. K-map provide a systematic method for simplified Boolean expression. K-map, on the other hand, provide a cookbook method for simplification. After completing this section, you should be able to construct a K-map for 3 variables. Determine the binary value for each cell in the K-map. Determine the standard product term represented by each cell in the K-map, and explain cell adjacent. Okay, and identify adjacent cell. Now, the purpose of the K-map is to simplify a Boolean expression. A K-map is similar to the truth table because it presents all of the possible value of the input variable and the resulting output for each value instead of being organized into the column and row like the truth table. So basically they're telling you, K-map like exactly the truth table, but they not go by each column and row. They make it the map. The K-map is an array of cells in which each cell represents a binary value of the input variable. The cells are arranged in a way so that simplification of a given expression is simply a matter of properly grouping the cell. Now, K-map can be used to expression with 2, 3, 4, and 5 variables, but we only discuss only 2, 3, and 4, not 5. Okay? The number of cells in the K-map as well as number of rows in the truth table is equal to the total number of possible input variable combinations. For 3 variables, the number of cells is 2 power 3 to be 8. You can see 1, 2, 3, 4, 5, 6, 7, 8. 8 cells. Like the truth table, you get 2 power 3, you get 8 combinations. Okay, 4 variables, you get 16. Now, this is a given you sample of the K-map for 3 variables, C, A, B. Now, this is a cell, a cell, and C equals 0 and C equals to 1. They're telling you anything in here, C will be 0. Anything on this cell here, C will be 1. Okay? On the left side, AB, A will be a first column, 0, 0, 1, 1. B will be a second column, 0, 1, 1, 0. Okay. So now they want the product for each cell. If I'm stayed right here, you look up, you see not C, right? C0 means not C. A0 means not A. B0 not B. So this cell for the product, not A and not B and not C. Okay, how about this one?
Not A, B, C.
Not
A,
not
not
A,
A,
B,
B,
C.
C.
How about this one?
A, not B, and not C.
Okay. So basically for each cell, they get a product and you need to identify. Okay, so this one, we just let you know. Okay, 4 variable, you get 16 cell. Okay, on the top, C will be the first, 0, 0, 1, 1. D will be a second, 0, 1, 1, 0. On the left, A will be on the first column, 0, 0, 1, 1, 0, 1, 1, 0. And this is the product for each cell, but we're not using that. Too much input. Cell adjacent. Adjacency. The cell in a kernel map are arranged so that there is only one single variable chain between adjacent cell. Adjacent is defined by a single variable chain. In the 3 variable map, 0, 1, 0 cell is adjacent to 0, 0, 0. You can see they get a 0, 1, 0, 0, 0, 0, only one variable changing. One here, 0 here, and the other will be the same. That's what they come up with the adjacent, okay? Physically, each cell is adjacent to the cell that are immediately next to it on any of its 4 sides. A cell is not adjacent to the cell that diagonally touch any of its corner. Also, the cell in the top row are adjacent to the corresponding cell in the bottom row. And physically, each cell is adjacent to the cell that are immediately next to it, or any of its 4 sides. A cell is not adjacent to the cell that diagonally touch any of its corner. So I just quick go through it, okay? After complete text section, you need to know. They will telling you map to standard SOP, sum of product into K-map. Combine 1 on the K-map into the maximum group. Determine minimum product term for each group. Combine minimum product term to form sum of product expression. Convert the two table into the K-map, or for simplification of represented expression, you don't care condition on the K-map. Mapping a standard SOP, sum of product. For an sum of product expression in the standard form, a 1 is placed on K-map for each product term in the expression. Each one is placed in a cell corresponding to the value of a product term. For example, for product A, B, C, 1 in got into 101 cell on 3 variable. Okay, when sum of product expression is complete map, there will be number of 1 on the K map equal to number of product term in the standard sum of product expression. The cell that not have 1 supposed to be 0. Now, your reading may be a problem, but if you understand how to do it, we'll be happy you here. First thing you get is a K map for 3 variable. The equation will be not A, not B, not C, or not B, not A, not B, C, or A, B, not C, or A, B, A, not B, not C. So you can see how many 1 will be put it in K map. One product will be 1. 1, 2, 3, 4. So the first one you map 1 into not A, not B, not C. You know that is a not A, not B, not C, so you put a 1. Okay, a second one, not A, not B, not A, not B, C. You put another 1. Okay, and so on. For this guy, you get A, B, not C. A here, B here, not C here. You put a 1. And the last one, A, not B, not C. A here. Okay, let's see. A here, not B, not C. That is how can we map the product to the K-map by logical 1. And anything else, nothing, they will be 0. Now, any question? How to map the equation into the K-map? No question. You guys know how to do it? Right now, we're just talking about mapping. And if you see the example, there any question on also on that example? I can try to help you out. If you're learning engineering, you're using all the time. The thing that you have to design. Technician will not design any circuitry, but the engineer will have to design the circuit. Then you have to need the K-map.
Hey, Mr. Pham, did you say the purpose of this is to eliminate or determine how many ICs you'll need to build a certain, say, product or whatever?
Yeah, that's what we're using the K-map doing. Instead, you're using Boolean. We don't have a, you must be using the K-map. That's an advanced system. Boolean, H2O. Now my question is, if I get an equation or expression, I want you to map into the K-map. Can you do it or not? That is the question in this part right now.
Mr. Pham, could you please explain again the example that the first example that you have there?
Now, I'm talking about example here. You get this equation.
Okay.
So they want you to map into the K-map. That means they wanted you map into the K-map here. First thing I'm looking into that, I know I get 4 logic 1 in the K-map. Each product not A, not B, C, that you get a logic one. So now you have to look into here to see which one is not A, not B, not A, not B, C. That's why you get this one. Right here. Then you go to a next, looking for not A, B, not C. So you have to identify the cell. Okay, not A right here. B is one is the B, not C here. So you get another one. That means you get a product. I want you to map by logical one into the K-map for each product. Can you do it or not? Or anything confusing, anything not understanding? We have to understanding that first before we go to the next part.
Once you get this, what do you do with it?
Next one. We'll be looping.
Oh, okay.
Okay, what I want, you do this one for me. You have to do it before I can go to the next one. They get one, not A, B, C, or A, not B, C, or A, not B, not C. Map it
Oh,
to the K-map.
okay.
Make sure you have to do it, okay? You really want to understand, you want to learn it, that you have to do it. Not just the what's only, except you already know how to do it.
B, C. Right there.
So, Mr. Fan, the first expression, not A, B, C, should be on the second row, second column. Okay.
That you get
Okay.
on mine. That means you're right.
Mhm.
Okay, you add one there. Okay.
The next one, you should put a 1 on the bottom right. Yeah. Then A, not B, A, not B, not C. And then put a 1 next to the one over, directly over.
A, not B, not C.
Right.
Yeah.
Yeah, right there, right there. That's it.
Okay, you get that?
Right.
Okay, no question, right?
Yeah, Mr. Fan, just to double check, this kind of map is to reduce the number of gates to express the expression that you have there. That is the main use.
That's what we're talking next. That means you're looping, you get a new equation.
Okay.
That is the minimum. Otherwise, if you draw this equation circuitry, you can get a lot of gate.
Got it.
Okay, now this one I'm not doing for you. Okay, you just look into that. The thing is, we not try to deal with 4 variable. Okay, that example. Okay, now I want you to do on the related problem. You go over the example first. Can you understand or not? If you done on that, then I want you to get related problem. Okay, now working on example. Not A, or A, not B, or A, B, not C. Can you get the same, like the solution already there?
Hey, Mr. Fair, my question is, okay, like it's not A or not A, and then you got A, not B, and then you got or A, B, not C. When you only have one of them by itself and you look at the table, how do you, what do you put in for B and C if there's no B and C? For instance, you got.
That's what I let you thinking.
Oh, okay.
I try to see who can get the same.
Yeah, I see what you're saying. Okay. Just give us a second.
Yeah, after thinking. Okay, so I have to go through that for you. Okay, otherwise we don't know time. First thing you see, not A, right?
Right.
When you see not A, you don't see any B, C. That means B and C, they don't care.
Oh, okay, don't care.
Okay, so wherever you get not A, you enter 1. Okay, so not A right here, you enter 1. Not A, where? Not A here, right?
Yeah, that's 1 as well.
Okay, and that will be 1. You get that will be 1.
Okay, I see what you're saying. And the next one is A.
When you get only one single variable, you don't care the other one.
And the same thing for the AB.
Not B.
Right.
Okay, not B right here. Right?
Right.
And here, the thing is they don't care on C.
Mhm.
You don't see any C.
No.
That's why. The last one, A, B, not C. A, B, not C. That is what you get.
Okay, for the C, you said for the middle term, was A, not B, and you don't see a C.
That means you don't care C.
So you could put whatever you want for C?
Right. But they have to go with the A, not B.
Okay.
Okay, try the related problem. See how much you understand. If you guys done, let me know. I can go through it. Okay, B, C. That means B equal to 1, C equal to 1,
Right.
right?
E equal to 1. C equal to 1. Yeah,
They don't care A.
right.
Not A, not C,
Not A.
not A. Okay,
First column, first
First column.
row, second column, second row, first column.
is that right?
Yeah.
Yeah, for the not C.
Okay,
Hey, Mr. Pham, so basically, look like you're saying, like when you get like, say, the first example where you got A or B, you know, if you only have like one term or two terms, you just worry about that one term only, and then everything else is don't care. If you have two, if you have two of them, you worry about the two terms, and then the third,
Exactly.
and then the third one don't care.
exactly.
Okay, all right, all right, all right. All
Don't
right,
care that for variable.
all right, okay.
Okay, now,
This stuff here.
Carnot map simplification of sum of product expression. The process that results in an expression contain the fewest possible term with the fewest possible variable equal to minimization. After an sum of product expression has been mapped, a minimum sum of product expression is obtained by grouping the first and determine the minimum sum expression from the map. Grouping 1. You can grouping 1 on the K-map accordingly to the following rules. By enclosing dot adjacent cell containing 1. The goal is to maximize the size of the group and to minimize the number of the group. A group must contain either 1, 2, 4, 8, or 16 cells. Okay? That means you can looping 1 or 2 or 4 or 8 or 16. You can say you cannot loop 3, cannot not loop 5, 6, 7, okay? Which are on power of 2. In the case of a variable map, 2 power of 3 will be 8 cells in the maximum group. Each cell in a group must be adjacent to one or more cells in that same group, but all cells in the group do not have to be adjacent to each other. Always include the largest possible number of 1 in a group in accordance with the rule number 1. Each one on the map must be include at least one group. The one already in a group can be including in another group as long as the overlapping group including non-common one. Now we're talking about grouping here. First, for the grouping, So I can try to do a group one without any adjacent. If you're looking into in this one right here. Now I carry you adjacent. One here, they get only one line here. Adjacent. One and one here will be adjacent. Neighbor. Okay? They will be a neighbor. But this one only one. No neighbor. That's what we want to loop first. So you loop that guy first. And now you write the expression. They will be not A, not B, not C. And or with the next one. Now, you can say this guy and this guy will be a neighbor. So you can combine it, looping that guy. Okay. Can you tell me what the product?
Not A, B, C.
A,
Not A, B, C.
okay, now, if you're looking on that loop, look up C equal 1, correct?
Right.
Yes.
Look into the left. A equal 0, A equal to 1. They have to be ignore that. You cannot inside the loop and they both 0 and 1. So basically, to me, they will be BC.
Okay.
Okay? And the last one in here. Okay? And they get a neighbor. Next one. So you can loop that guy. That will be overlap. That's okay. You can borrow that one. So what you get?
AB.
Perfect. Okay? Now you're telling me number B. You can loop it, correct? That means you really understand how to working with the K-map. Mapping in and looping.
So looks like the first ones that you have there are equal to ABC.
Okay, let's say if you want to loop this guy, loop this guy.
Mm-hmm.
That means neighbor here, right?
Yep.
Okay, so the equation will be not A, not C. Correct? Now you tell me, I want this guy. So you will be go this way, right? So they will be,
Not B, not C.
come on. This guy. Who tell me this guy?
AC.
AC, correct. Okay.
Hey, Mr. Pham, so I make sure I get this right. If you go back to that first loop you did, you put down not A and not C because, okay, so you got not A,
The thing is, you see on the first loop, A, B0 and B1.
right?
Ignore that.
Oh, okay.
They will be canceled out.
So A is 0.
That's why I get the first one will be not A, not C. I said I go step by step. If you do not understand, just stop me. You have to understand, okay? And you can see that are very easy.
Oh, I get, so you got not A and not C, and then B on the first block is B would be 0, and then the next block B would be 1. So then you just disregard it.
Yeah, so that's what I get AC, right?
Right. Not A, not C.
Now the second one,
Oh, the second one,
AC.
AC, okay.
Not A, not B.
And now will be the last one. The last one you get two guys, one here, one here. Okay. Now, this like the paper, when you wrap it around. So on this side here and this side here will be adjacent. Okay. So last one, you have to go that one here. Go with this guy. So what you think you get?
Not A, not B.
Who get the right answer for that one?
Is it not B?
Perfect. Yeah, you're very good. Okay, now you can see on that loop, C01, don't care C, okay? And you can see on the loop from the top to the bottom here, A0, A1, forget A. You can get B0, B0. That's why not B. Okay, I can loop number C for you. I let you try to do it. Let me know the answer. I believe if you will understand, then you can do. Okay, the first one, I can tell you, I want it first.
A,
What you get for that loop?
C doesn't matter. D. A not B, D.
Sorry. You're right. Not B. The next loop.
B, D. D. Not C. Not A, not C.
All right. And the last one here.
Not A, B.
Not A, B. Yeah, you okay. Very good. When you're going from the left side to the right side, don't read anything on the top. They don't care. When you're going from the top to the bottom, then you ignore anything on the side AB. By the way, I can go for D for you. Okay, who can do it for me? The first loop I can carry you. I want this guy.
So C. A, not B, C.
Perfect. And the next one, I want this loop.
B, not C.
Perfect. Okay, and the next one, let's see. I want this loop on the left, on the right. Again, when
Not
you're
D.
going from top to the bottom, ignore AB,
Not D.
not D. Perfect. You can be engineering for sure. if you keep going. Not a big deal. If I teaching, you can follow it. I can guarantee someday you keep going, you can be engineering. No problem. We try to build a basic understanding in electronics and also in digital. You go into the university, college, you're still learning again. But the university, you engineering, you have to, the only thing you need to design. Okay, any question up to this point? And in your tech show, when you get a quiz, that means I let you download the quiz and given you 1 week to upload it. The thing is on that one, it's not easy to using multiple choice. We have to do on the paper. No question? Okay, that's just a sample thing for you guys to look into that. Okay. Okay, just for you to look into that. See how they look. Okay, so next Tuesday, I will be going with you on the D lab. That means how can you working on Excel on the K map on the D lab to make it part. That's the first thing. Then now, how do we converting, okay, from Excel to the program? And how can we build the circuit? How can you run the test to see they part or not? So sometimes you get 1 week, you can get a few lab done. The thing is that you know how to do it, then that's very simple. Okay, any more questions? Anything?
Hey, Mr. Fent,
Yeah,
I put together a simulation real quick for the De Morgan's law.
no,
Hey.
I don't do anything with the Morgan law.
No, what I'm saying is I put together a simulation to show the De Morgan's law. That example that you showed, if you want to look at it, if not, then we can do it next week.
Okay, now you can go into the P-SPICE, right? Draw the circuitry, already know the circuit.
Right, you can use the component or the gate.
Yeah, you can draw the circuitry before you can minimize. And after you minimize, you can get another different circuitry. Even the output will be the same, but will be less number of gates. If you want, you can draw the second one and you run, you can see the output will be the same for each combination. And basically, we not try to play with that. Let's wait the time. Okay. So next week will be see something else will be happen to the program. They let me know they will be trying to return food. Okay, I'm waiting for to see what they mean. Return food. Okay, that means if they try to return the program like before the COVID-19, so that means you can get 4 days in the lab. That means the lab will be open Tuesday, Wednesday, Thursday, Friday. But we'll see what's going on next week. I hope they try to return this program into like what we did it before the COVID-19. Otherwise, still give me a lot of problem. And that will be delays for the student to get the certificate. The hour, I don't care. The thing is, you guys been up to this point, I believe you will be no problem with the hours. Only thing is we want you to get it done. What we want you to get to it. And if you get the certificate, you want to looking for the job, let me know. I will be helping you. Which company in the San Diego? They are hiring. Okay. The thing is, I get a lot of students working in the company in San Diego, especially in defense company. Okay. They working inside, so they know company want to hiring or not. Apply for the job. You have to get a basically confident how to using the equipment. And some very, very basic from DC, electronic, and a digital. That's a basic. Okay, then I can let you know. Especially the student in the program, okay, I know you understand it. And you better let me know your name. The thing is, when you apply for the job, company will be normally referred to the program. You're asking me for recommendation. So if I don't know who are you, then it's hard for me. Like in the past, I be in the class on the top. So who can do, who cannot do it, I know. Okay, so if you don't have any question to me, then good night, everyone.
Good night, good night, good night.
Good night, Mr. Pham.
Good night.
Good night.
Good night.